Hi, my name is Alex Fleischman, and welcome to the video overview for the Wimshurst generator demonstration. Alright, so let's start this demonstration off. This demonstration will familiarize students with the Wimshurst machine and how it works. Students will gain an understanding of the properties of the machine and how charges on each head interact with one another. Alright, let's work through the procedure. First, place the Wimshurst machine on the table, and briefly demonstrate how it works by placing the metallic heads approximately 2 to 3 inches apart and turn the crank. Allow the machine to create a spark a few times. One of the heads carry a positive charge, and the other carries a negative charge of equal magnitude. Both heads are stationary, therefore to, in quote, relieve the electric force between the two heads, a spark is created. Students will learn more about this machine in the electric field demonstration. Let's continue with the procedure. Let's take a piece of cotton and tear it into a small piece. Then, place the heads of the machine far enough apart such that a spark cannot travel between them. Then turn the crank of the Wimshurst machine for about 10 seconds. Quickly drop the piece of cotton ball onto one of the heads of the Wimshurst machine. Then observe as the cotton ball jumps back and forth between the two heads. Alright, now we're going to mathematically find why the cotton jumps from head to head. Let's begin by stating that the final charge on the cotton is equal to the final charge on the head. Let's also state that the final charge on the cotton equal to the final charge on the head is equal to the initial charge on the cotton plus the initial charge on the head divided by 2. Therefore, half of the net charge will remain on the cotton and half will remain on the head. The reason the cotton jumps from head to head will get a lot clearer when we work through this example. The cotton ball is initially dropped onto the positive metallic head. The cotton ball has no initial charge, but the positive metallic head has a charge of positive 10 coulombs. What is the final charge on both the cotton and the metallic head? Well, we must use the equation we stated before. The final charge on the cotton is equal to the final charge on the head plus the initial charge on the cotton plus the initial charge on the head divided by 2. Now let's give values to our stated variables. So the initial charge of the cotton is 0 coulombs, and the initial charge on the head is positive 10 coulombs. Therefore, the final charge on the cotton is equal to the final charge on the head, which is positive 5 coulombs. So how will the cotton act when it acquires said charge? Well, the cotton will now experience a repulsive force with the positive head, because positive and positive charges repel, and an attractive force with the negative head, because positive and negative charges attract. Therefore, the cotton will now jump from the positive head to the negative head. So now we figured out why the cotton jumps from one head to the other, but why does it jump back? Well, we're going to figure out why. Let's continue with the problem. The cotton ball has jumped to the negatively charged head. Remember, both heads were equally but oppositely charged, so the negative head still has a charge of negative 10 coulombs. So what is the final charge on both the cotton and the negative head? Well, we're going to still use the same equation we made before, that the final charge on the cotton is equal to the final charge on the head, which is equal to the initial charge on the cotton plus the initial charge on the head divided by 2. Now let's substitute our variables. The cotton has a charge of positive 5 coulombs, related from its interaction with the positive head. The charge of the head is still negative 10 coulombs. Therefore, we could state that the final charge on the cotton and the final charge on the negative head is equal to negative 2.5 coulombs. So how will the cotton act once it acquires this negative charge? Well, the cotton will now experience a repulsive force with the negative head due to negative and negative charges repelling, and an attractive force with the positive head because negative and positive heads attract. Therefore, the cotton will jump back to the positive head. This process will repeat until the net charge of the cotton, negative head, and positive head system has completely dissipated into the air. Alright, let's go over some review. Conductors are materials in which charge can easily flow. We learned this in the beginning of our presentation. When two conductors touch each other, the sum of the charges of both materials will evenly distribute through both objects. This process is known as conduction. The equation for conduction can be seen as follows. The final charge on the cotton is equal to the final charge on the head, which is equal to the initial charge on the cotton plus the initial charge on the head divided by 2. Note, The head and the cotton can be replaced with two different conducting materials. For further questions regarding this demonstration, continue this video. However, at this moment you may stop the video and continue with the Smart Notebook presentation. Alright, let's go over some questions. We know that in a Wimshurst machine, one head has a positive charge and the other head has an equal but opposite negative charge. Why does the cotton ball jump back and forth between the two heads? Well, the cotton begins with no net charge and acquires a net charge when it is dropped on one of the heads. For the sake of the answer, let's assume it was dropped on the negative head. The cotton will acquire a net negative charge and will be attracted to the positive head. Once the negative charge on the cotton is strong enough, it will be pulled toward the positive head. The magnitude of the negative charge on the cotton is less than the magnitude of the positive charge on the head, so the cotton will gain a net positive charge. This is called conduction. This positive charge, when it becomes strong enough, will cause the cotton to jump back to the negative head, and so on, and this will repeat like a pattern. So why, after a long time, does the cotton stop jumping between the two heads? Well, the heads are too far apart to discharge the high voltage through a spark, so they need to do so through the cotton. The cotton will jump to another head when the charge it acquires is strong enough that the force pulls it across the separation between the heads. Through this process, the heads essentially discharge through the cotton, slowly transferring part of their total charge to the cotton to try to neutralize it. Eventually, there will be not enough charge on one of the heads to allocate to the cotton, so the cotton will not be able to jump anymore.